All right, we are moving into dividing whole numbers and dividing with decimals. Dividing with whole numbers should be a review. But first, we're going to review fact families, and we did this when we started adding and subtracting decimals last week or the week before, so I'm not going to review what a fact family is. I want you to finish the fact families for 1, 2, and 3, and I'm going to give you 2 minutes. Any questions? Go for it. Who can tell me another member of number 1 fact family? Asher? 72 divided by 9 equals 8. Oh, that's it. Oh my God. 9 times 8 equals 72. The last one. So guys, fact families, they have the same family members. 8, 9, and 72. Why does it work with these problems? Because I can't say 8 plus 9 is 72. Why does this work? Yes. What's the mathematical term for opposite operations? Danielle? Inverse operations. Yes? Yep. All right, so number 2, you should have had 84 divided by 14 equals 6. 6 times 14 equals 84. And 14 times 6 equals 84. And number 3, you should have had 2,464 divided by 8 equals 308. 8 times 308 equals 2,464. Please cover your mouth. And 308 times 8 equals 2,464. Easy, easy, guys. I don't understand why some people are just sitting there staring in the blank face. All right, next page. Yes. Oh, wait. Yeah.
Let's start with some basic definitions. So we understand multiplication and division, how these work out. Right? So we learned division helps determine how many times one number and another number. So division determines the quotient given a dividend and divisor. So find out how many groups are going to change this to multiplication. It's really simple. I say, okay, how many groups were there? How many were in each group? That's going to tell me the total that I divided up. Does that make sense for everybody? This is why multiplication and division are related. So we can look at multiplication and division as fact families because they're directly related. We're using the same numbers in multiplication and division. They're just in different places. Okay? Now one thing we want to look at is if I'm looking at an expression like 48 divided by 6, John evaluated the expression using the following strategy. He knew from his fact family 6 times 8 is 48, correct? Everybody good with that? So now I'm looking at 48 divided by 6. He said that's going to be 8 because that is part of the fact family. Now, admit I was reading the homework, I missed it, that Mr. Shannon last time did this, I'm assuming she did as well. When we look at multiplication and division, we call those inverse operations. In other words, I'm using the same numbers, they just go together in different ways. That's how we become fact families. One other key note up here are quotients. They can be whole numbers, decimals, or fractions. The way I know to do decimal or fraction is based on how it was given to me. So if they give it to me as fractions, I'm going to make it fractions. If they give it to me as decimals, I'm going to make it decimals. So again, when we're doing a quotient, if they give it to me as fractions, I'm going to do it as fractions. The answer is decimals. So what strategy would you say John used to evaluate this question? Hopefully I gave you enough time to forget.
Yeah. You get that 6 times 8 is 48. You know that like 8 is divided by 6 and only be 8 is using knowledge.
Knowledge of what?
Oh, it's the root. Inverse.
Inverse operations, what do we call them in the open exercise? Fact families.
Oh, you use.
I do like the fact Max brought up he basically used inverse operation. Or fact family. You can say it either way. You basically use the inverse operation, but by understanding 6 times 8 is 48, we knew that there are 8 groups of 6 in 48. So identify the dividend, the divisor, and the quotient in this statement. I'll give you guys 1 minute to do this by yourself. Write it right on your paper, right above the numbers. Okay, so the key on this is understanding what each of the numbers is, right? So the dividend is which number?
48.
48. What I'm dividing up, right? So the dividend is the number I'm dividing up. That's the 48. The divisor is how many are going to be in each group, correct?
Yep.
So that's how it was going to go right after the sign is the divisor. This is how I'm dividing it up. Our quotient tells us how many groups, or the answer to the division problem. So there's our quotient. Does that make sense for everybody? Okay? So, which values in the statement 48 divided by 6 can you switch and the statement is still true? Which numbers can I switch around? You do?
The quotient and the divisor.
Okay, the quotient and the divisor. Why are they still true?
Because they, in multiplication, you can use the inverse and the quotient times the divisor equals the dividend, which means the inverse operations.
Good. Or, what's an easy way to say it? What did we use to start?
So we have the property.
We have community property division.
So that
Fact family. Fact family to switch is 6 and 8. I know 48 divided by 6 is 8. I know 48 divided by 8 is 6. They're in the same fact family. Is this reasonable for evaluating any division expression?
so
Why not?
like because you didn't know the multiplication like that.
If I know the multiplication, why can I use fact family? So is this reasonable for any division problem? The key is that you need to know the fact family for it. But yes, as long as you know the fact family. Doesn't matter. So if we use our fact families, we know the fact families, that will work for any problem. Because those are always going to be directly related. Everybody okay on that page? Which part are you not okay on? Just writing? Okay. Go to page 147. I'm just going to go ahead and put a caveat on front of this. This is only design view of you who may like this type of format. I know there are some elementary teachers Teach a very similar strategy for doing multiplication and division. So that's how you've been taught. You're familiar with this. It will work. But I'll be honest, I'm not a huge fan of this. Okay. So Lori is looking at 34,098 divided by 6. Do you think she knows the fact family for that?
No.
No. So instead, she's going to use what we call an estimation strategy. In the estimation strategy, what you're going to do is kind of break the number down by pieces to figure out how much you have left. DJ said the mathematical term is partial quotient. But it's not truly partial quotients, because you use estimation to get close. But it's the same concept as partial quotients. So sure, she's going to start and say, again, dividing 34,098 by 6, right? So she's going to start at the biggest number she can do, which is around 30,000. So she knows 6 times 5,000 gives her 30,000. So she puts the 5,000 on top, and she subtracts the 30,000 to figure out how much she has left to get rid of. Everybody okay so far?
Yeah.
Okay? She then looked at that, she said, okay, 6 times 7 is 700 is 4,200, that's too big. So I'm going to go down, so 6 times 600 gives me 3,600, so that's the next number. So the 3,600, she's going to take away the 600 she puts on top to keep track of what she has done on her estimation so far. Subtracts 4,098 to 3,600, and she gets 498. So 498, she tried 6 times 50, got 300. That's too small. So she went up quite a bit. She went to 6 times 80, got 480. That's actually really close. So she subtracts the 480 and then puts the 80 into her list of what she's done for her estimation so far. Subtract 480 from 498, got 18. Now she knows that's just 6 times 3. So she takes that remainder out, puts the 3 on top, and then she adds up all of her estimations that she used. Figure out that 34,098 divided by 6 gives her 5,683. Everybody okay with this one? It's really, this is what you're going to be doing in long division, except you're not going to be writing down all the place values, guys. Literally, all she did was 6 goes into 34 5 times. Then she does bring the 0 down.
But that's all.
So it's the exact same thing as what most of you are going to do. She just kept the place values for each individual place, put them together. In each step, why did Lori subtract after she determined the estimate? As she estimated, why did she subtract her estimation? Well, apparently DJ and I are having a conversation today. DJ?
It's because division just repeated subtraction, so they were subtracting it each time so they don't have to add too much. If
You're close.
they go to deck.
It is repeated subtraction. So by subtracting your estimation, what did you find out?
How much you have left.
How much you have left. So why did she do the subtraction? Find out how much she still had to get rid of. That's all she's doing. She's taking each of her estimates and then subtracting it to figure out how much more she still needs to get rid of. And she keeps doing that until she gets down to 0. So given that concept of that strategy kind of makes sense to you now? Okay. I'll be honest, not a strategy Mr. Cannon or I are real big fans of, but it is one that can work, especially if you've done partial quotient before. Okay, Rob and Morgan agree with Lori's logic. They shorten the process. So you can see with Rob, instead of having to add all of them up, he's like, oh, they're all different place values. So I can just make this 5,683. That's really the only difference between his strategy and what the first one was. Morgan did it the way Mr. Jen and I would like to see you guys do it. literally all you're doing is going by place value all the way across. One really, really big key in this, Marissa, is you have to keep track of every place value, guys. If you skip a place value, it's going to cause you issues. Each time I do the place, I bring down the next number. One big key, if my remainder is bigger than my divisor, that's telling you you didn't go big enough. So you'll need to go back and go up by one at least on the number that you use. So we compare Rob's and Morgan's strategies. What are the similarities and what are the differences? So if I look at Rob and Morgan, what similarities do you see? What differences do you see? David?
This one's basically standing out. Rob is all subtracting. Now Morgan is just, yeah, basically the same thing.
Okay, so Rob's subtracting bigger numbers. That's the difference. What similarity do you see? Sure.
The numbers they're using to subtract the only numbers, they're all multiples of 6.
Okay, they all use multiples of 6. Anything else? Did they get the same answer? I would say that's a big similarity, right? And that's one of our big keys. If I can consistently do it and get the same answer, is that mathematically viable? What do you think, Rain? Okay, you didn't answer. Yeah.
Why are you raising your hand?
Please raise your hand. I called you. Everybody good on those? Okay, Carnegie Middle School did a month-long food drive and clothing drive to assist in disaster relief. They collected the following items: 13,212 cans of food, 9,472 blankets, 19,456 batteries, 26,112 bottles of water. If they want to make 256 disaster relief shipping crates, how many bottles of water will they put into each shipping crate? How would I figure that out? Well, let's take a look. Morgan said she used her strategy from earlier. She took the 26,112 divided by 256. And I'll be honest, guys, they messed this up, so I'm going to have you fix it. What she did was said, didn't go into 20 at all, right? Won't go into 2. Won't go into 26, will it?
No.
But it goes into 261 one time. So she stacked it to 256 and got a 5. Brought down the 1. How many times was going to 1? Or 51, sorry. 10 times with 256 going to 51.
0.
0. So then she brought down the 2. Goes into 512 twice. Make sense?
Yep.
Okay. Dustin said 12 bottles of water in each crate. What did Dustin do incorrectly? I want you guys to look at it as a table, talk about it. I'll give you 30 seconds. Come up with one. What did you guys come up with? What did Dustin do incorrectly? Yeah. Yeah. I'm going to say place the 0. You got to the 51 and then put a 0 on it. For the place value. Does that make sense? David? Okay. Well, that's really smart to say it like that. Okay, how could Dustin have checked his work to know his answer was incorrect?
You should have said like because like if you should check like if you're reading or not.
So how would he check it? How would he know that 12 wasn't the right answer? So how could he have checked? Estimation. Okay? He could have estimated. If he had estimated, he would have said something to the effect, okay, I've got something around 250 and 225,000. So that's going to go about 100 times. Would have been an easy estimation. If I know it's going about 100 times and my answer is 12, would I know something wrong? You should. Having checked my science homework, there's a lot of students that did estimations that were not even close to their answers, and they didn't seem to bother. They were bothered by that. Evan? Okay, what were you multiplying? Good. You couldn't have multiplied 256 times 12. Would you have gotten anywhere close to 26,000? No. You got somewhere a little over 2,000. Okay? Or multiply 12 times 256. Okay? Dustin should have 3 digits in his quotient. How could he have determined that before he started dividing? That guy gave us the answer. Could have estimated. Again, guys, should estimations be difficult to do? No. You're literally making the numbers easy for yourself to do. Is it hard to do an estimation then? No. But can it give you a chance, a quick check to the reasonableness of your answer? Absolutely, especially when we're doing so much with decimals, because your rules are different for adding and subtracting versus multiplying versus dividing. We have different rules for all 3 sets of those operations. You need to understand the rules for each of them, but in any of those cases, a quick estimation will help you understand if you're on the right track. So now we're going to give you a chance to actually do it. So use Morgan's method of long division to determine how many of each item they must load into each of the 256 shipping carts. So all you're doing is dividing the number that they've given you on the previous page by 256. You do that for all 3, A, B, and C, and then we'll come back together. This is longer division. I'll give you about 10 minutes. Although if you're really struggling like last class, I'll break in 5 and give you guys a quick hint on how to do it easier. Go ahead and get started. Yeah, I watched several of you kind of really struggling on this. I mean, I've got several of you that have not even written down anything yet. So I'm going to teach you guys a quick strategy that actually works really well, especially in a case like this, where I'm using the same number multiple times. You can actually make yourselves a cheat sheet, guys. Okay? So, in this case, the number I'm dividing by is 256, correct? So I can really quickly make myself a table of all of the multiples of 256. 1, 2, 3, 4, 5, 6, 7, 8, 9. Because if I build a table like this, all I'm actually doing is addition. And most of you guys are pretty good, even at 3-digit division, right? So I'm just going to take 256, I'm going to add it to itself. 6 plus 6 is 12. Carry a 1. 5 plus 5. 10 plus 1 gives you 11. So I'm taking another one. 2 plus 2. 4 plus the 1 I carried is 5. All I'm doing is adding this 256 time I get to a line. So 2 plus 6 is 8. Don't do it all at once. 1 plus 5. 2 plus 5. So I go 6 plus 8 is 14. Carry the 1, 6 plus 5.
11.
11 plus by 1. 12. Carry the 1, 7 plus 2. 9 plus the 1, 10. I'm adding 256 again. 6 plus 4. 10. Carry the 1, 5 plus 2.
8,
8. 2 plus 0.
2,
Bring down the 1. Yeah, just show that this is really quick if you're not taking forever to add two numbers. 6 plus 0, 6. 5 plus 8, 13. 2 plus 2, 4 plus 1 is 5, 1. 6 plus 6, 12. 3, 8, 9. 9, make that 9 good. 2 and 5 is 7. 1 comes down. 6 and 2 is 8. 5 and 9 is 14. Gives me a 2. 6 and 8, 14. 9, 10. 3. I now have all the numbers that I need to do my division. I just do my division. So how many cans of foods did I have?
13,300.
Thank you. 13,012. Thank you, Ray. Now I'm dividing this by 256. Now I just do my division. Will 256 go into 1? No, we'll go into 13. No, we'll go into 133. No, we'll go into 1,331. Yes, now I look and I want to get the closest without going over. So that's going to be 5. I subtract 1280. Gives me 1. Can't borrow. I have to borrow here. Gives me a 5. 0, 0. Bring down the 2. Will 256 go into 512? Yes, twice. Subtract 512. I get 0. Is that not easier?
It's easy.
So I've already done the chart. Let's make sure everybody understands. This one that came out so good. 1,792. 6. 13. There. That one is 2,048. So you have the chart. Got 2 more problems to do. Give you guys 3 more. Blankets over.
What, 19,456? Oh, wait, no, that's not it. No, it's
Batteries and blankets.
9,572.
9,472. Okay. So divided by 256. We'll go into 9. No, 94. No, 947. Look at my chart. That's going to be 3. Subtract 768. I have to borrow. 17 minus 8 is 9. I have to borrow again. 13 minus 6 is 7. Bring down my 2. 1792. Well, how many will it go? 7. Subtract 1792. I get 0. Okay. Let's try this again. Rain, how many batteries?
Okay, 19,156.
456. Divided by 256.
Nice.
We'll go into 1. No, 19. 194.
Yes. Go.
No, 1,945.
Yes.
Yes. 7. So subtract 1792. Gives me 3. Have to borrow. 14 minus 9 is a 5. 1536. 6. So, can you see how that chart can make this way easier for you?
yes, sir.
See.
Is that multiple chart hard to make?
No.
Should be. Guys, what all you're doing is adding the same number each time. So, just a quick hint for you. Like on division, because one thing you're going to learn on division, my divisors are going to be pretty big. So a lot of times a quick chart like this is going to help you. You can still do your estimation and check, which some of my students, I saw had done that, got this completed ahead of time. But the chart's an easy way to go. Okay, division problem. The remainder can mean different things in different situations. Sometimes you can ignore the remainder. Sometimes the remainder is the answer to the problem. Sometimes the answer is the number without the remainder, and sometimes you need to use the next whole number to find the correct answer. So when we are doing division problems and there's a remainder, you need to understand what it means. So let's take a quick example. The Red Cross collected 3,551 winter coats to distribute. There's 23 distribution centers. How many coats can be sent to each center? Mara's calculations are shown. So here's Mara's calculations. I will tell you up front, her calculations are correct. She said that she can send 154 and that 23rd coats to each center. Math replied you cannot have a fraction of a coat. So each will receive 154 coats, 9 coats left over. Who is correct? Okay, go ahead, talk about it at your table, write down. And you think Mara is correct. Madison is correct. Overwhelming, right? I have parts of the coat. Madison is correct.
Oh my gosh, this has that right. I didn't have that.
Okay? So, in these problems, one of the biggest things you need to do is think about our remainders and what that's going to do to help us with the problem. So, Carnegie Middle School, they're hosting a picnic for any 5th grader who's attending next year as a 6th grader. They're planning a picnic for 125 students. Each 5th grader will get a sandwich, a drink, and a dessert. They're ordering large sandwiches that each serve 8 people. If there's 125 5th graders, how many sandwiches should the committee buy? What do I think? What do you guys think I need to do? Buy what? Okay. Divide 125 by 8. Will 8 go into 1? No, we'll go into 12. Yes, 1 time. Gives me a 4. We'll go into 45.
Yes,
Yes, 5. Okay, I still have 5. So what do I do with this remainder? How many sandwiches does the committee need? I could continue dividing, but I have a remainder. The whole question is, what do I do with my remainder? What do I need? What do I need?
there's 5 people starting.
So, that's absolutely right. I still have five more people I can feed. So I need 16 sandwiches.
And plus we have 15 people.
Something else. What I need. So I need 15 and 5 more slices. So I'll need 16 sandwiches. How many extra slices would I have? 5. 3. Because I need 5 of the 8, right? I need 5 more of the 8 to feed everybody. That means there will be 3 slices left over. Okay, hold on. So, your homework tonight is just math. You'll notice it went up quite a bit. 24 to 30. We have now finished all your division operations, or all your decimal operations. So your next three sections in math, yeah, are all dealing with the different operations we've done over the last few weeks. Okay, good luck, guys.